Please like, share and subscribe the channel to show your support.
Today we are going to discuss about the DDA algorithm. DDA stands for the Digital Differential Analyzer, and generally we call it simple DDA. So before starting the algorithm, we should know the background of the algorithm, how we started the algorithm and how we can compute the different points on the algorithm. First thing is that what is algorithm? Algorithm is actually when we are talking about the algorithm for the single problem, we are having multiple solutions. But which solution is best and efficient, we are considering that solution. So we are having multiple algorithms for the same problem, that is DDA, Brescian and line drawing algorithm, and various algorithms are there. But we are going to discuss about the DDA algorithm. So before starting the DDA algorithm, we should know about the line. What is line? DDA, simple DDA is used for the line drawing algorithm. Simple DDA is used in the line drawing algorithm. So we should know what is line. When we are talking about the line, mathematically we are saying that line is composed of infinite points. Line is composed of infinite points and having start and end points. These two things are important. That is, the line should have the start and also the end points, or you can say that we should know the length of the line, that is the segment of the line. So and the next thing, what we said at the starting, this is a definition for the mathematics. That is, mathematically line is composed of infinite points. Remember that this is infinite points in the mathematics, but practically it is not possible to implement the infinite points on the line, because in the mathematics we are calling it point, and in the practical way we are saying it pixel. When we are going to display it on the display device, we are calling it pixel. Point is, the size of the point is negligible. Mathematical point, the size of the point is actually negligible. In mathematics, we are considering the size of the point is negligible. And the size of the pixel is actually practical unit. We are implementing this pixel on the computer screen, and it is having some finite size. So it is not possible to draw a line without infinite pixels. So the size of the pixel is actually finite. So we should remember, when we are discussing about the computer graphics, we are saying pixel, and at the same time we are calling pixel as a point, but exactly the difference is that pixel is having that finite size and point is having negligible size. Mathematically we are calling it point, and practically, or in the computer graphics, or in the display device system, we are calling it pixel. So be sure the difference between these 2 points, pixel and point. But when we are having the formal discussion, we are calling pixel as a point most of the time. But don't confuse, when we are talking about the point, its meaning is that it is practical pixel and it is having finite size. The next thing is that before starting the algorithm, we should know the background of the algorithm. What is line drawing algorithm? Algorithm is coming from the mathematics. So we should know the mathematics. The first algorithm, or you can say that the mathematical equation for the Cartesian slope intercept equation, we are having y equal to mx plus c. This is the basic equation of the line drawing algorithm. We know about this one. That is, from the geometry, we are having the equation of the line y equal to mx plus c in terms of Cartesian slope method. Next, what is the next thing? It is saying that we should have the start and end point, because the line segment we should know what is the line segment, what is the size of the line, otherwise we cannot draw the line. So we are assuming that the end points, or starting or end points, are given x1 comma y1 and x2 comma y2. So this is the end point. So we can calculate the value of m, that is m, or slope, y2 minus y1 upon x2 minus x1. M is, we are saying that this is tan theta in geometry, and the value of constant, it is y1 minus mx1. So this is the values we can compute, and we can calculate the values of different pixels or points on the mathematical line. So when we are drawing this thing, this is x direction, this is y direction. So this is the, suppose that, starting point, x1 comma y1, and this is the end point x2 comma y2. So we can connect these two endpoints with the help of multiple points, or you can say that infinite points, but practically with the finite pixel we can connect these two endpoints and we will get our line. The next thing is that how we can draw the line. We can draw the line on the graph paper or on the computer screen with the help of two methodology with the from this equation, that is y equal to mx plus c. The first method is that what we will do, we will unit increment the pixel in the x direction or point in the x direction. We will increment the pixel or point in the x direction with unit increment, and then we will compute the value of y. And in this case the value of y we can calculate y equal to m into delta x. Delta x stands for the xk plus 1 minus xk, that is the next successive pixel value minus the previous value, the value of delta. This is the difference between the next pixel or next point and to the current pixel. M is the value we can calculate from here, that is y2 minus y1 upon x2 minus x1. Remember that this value of m is always fixed during the plotting of the line, so we are not going to change the value of m. So when you will use the unit increment, we can draw the line in this way, that is, this is the x direction. Suppose that this is the unit increment interval in the x direction, and same time we are having the y direction unit increment, but y direction may be sometime it have the value for the y 2.5, that is because it is mathematical calculation, so it may have value of the y 2.5, 3.3, like that. So how we will see later how we are going to overcome this problem. Suppose that this is the first point, we get the first point, we computed. Next we incremented the value of x, that is this time x, the value of x is 2. So maybe the value we are getting for this one is this. For the next unit increment we are computing again this value and we are getting the value at this point. Next time we are getting the value at this point. We are using this equation y equal to m into delta x. Delta x is unit increment, we are incrementing 1 unit, and we are computing the value of y with the help of m. So finally when you will get the final point, that is your start and end point, when you will reach to the end point we need to stop, that is this is our final point or stopping point. Now you can connect these points and you will get the required line. The next thing is that the next method, we are saying that the same line, the same method, the line equation is same, but we can change the method. What is the method? We will go for the unit increment. We will go for the unit increment, the pixel in the y direction. Now this time we will reverse the scenario, that is we can change the direction into the y direction, compute the value of x. This time we will compute the value of x. The value of x you can calculate with the help of this equation, x equal to delta y upon m. Delta y is yk plus 1 minus yk, and it is unit interval. So in this case, how you can compute the point or pixels? Suppose that this is x direction, this is y direction, this is the value of x. Suppose that this is the y1. So at the time of y1, what is the value of x1? We can compute from here. That is the starting point, or you can say that the starting point. And the next value of we will calculate. We will increment the value of y in the y direction with unit increment, and next we will calculate the value of x from this equation, and we can compute this thing. The same thing we will go in the previous manner, that is in the y direction we are incrementing one by one, pixel by pixel, and then we are connecting the line. We will get the line. These are the two methods. We can follow any one of the methods to get the line. Now we will discuss about what is algorithm, but that is what is the when we are going to display this line into the practical line. That is when we are going to display this method into the practical, what the requirement we need to display the line. So these are the four basic requirements for the line drawing algorithm. That is from mathematical solution to the practical implementation. we need these 4 points. We can follow any algorithm, but they should follow these 4 guidelines. That is, the straight line should appear straight. When we are going to draw the straight line, it should appear straight. It should not display in the zigzag manner. That is not in this way. The next requirement of the line drawing algorithm, that is, the start and end point should be accurate. That is, what is the starting point? The line drawing algorithm should start from the starting point, or the start point is given, and at what time it is going to end. It should end at the end point accurately. That is, the start and end point should close, or starting point should be exact point what is the given our requirement, and the end point should be at the end point. It should not be it should not end to the x end minus 1 like that. So it should be start and end accurately. The next thing is that constant brightness. This is a very important point. That is, the line should have the constant brightness along the path of the line segment. What is the reason for this one? Suppose that while computing the values, we are getting the values 2.5. So what is the meaning of 2.5 in the practical or in the pixel way? We cannot glow the pixel partially. It is not possible. Either the pixel, when it is glowing on the screen, it is glow, or it will not glow. So in this case, we cannot say that this is the pixel, that is 0.5, so we will glow half of the pixel. It is not possible. This is completely wrong. So either this value will be 3 or 2 depending upon the algorithm. So the brightness should be constant, that is, the pixel should glow completely. It is not possible to display the pixel partially. The next thing is that, which is very important part of the algorithm. For any algorithm, we are accepting those algorithms which is having efficient and less complexity. So the line should draw, the algorithm should draw the line rapidly. That is, it should not take more time. That is, it should not waste its when we are writing the algorithm, it should not be complex, that it is calculating pixel by pixel, and it is calculating more in the background. So it should draw rapidly. So these are the 4 basic requirements for the line drawing algorithm. Now we are going to start about the DDA algorithm. DDA stands for the digital differential analyzer, and it is also referred as simple DDA. But when we are drawing the algorithm with DDA, it is having some assumption. That is, first assumption is assumption 1. The line is processed from left to right. The line is processed from left to right. That is, on the computer screen, we are having the line which is having the starting point at the left side and the end point at the right hand side. So you can say that this algorithm is depend upon the start and end points. That is, if the start and end points having its location or position, suppose that this is the start point and this is the end point. So we are saying that the start and end points, starting point is at the left hand side and the ending point is on the right hand side on the computer screen. So based upon that one, we will follow the different cases. We are having the 2 cases for the first assumption, that is, when we are having the line starting from left to right. And remember that this algorithm is depend upon the starting and end point. Don't change the pixel value while computing. So the pixel value, what is given to you the starting point, and what is given to the end point, we will follow the same sequence. We cannot interchange the sequence of the pixels. So the first case is that if the value of m is less than equal to 1, that is, when the slope value is less than or equal to 1, then what we will do, we will follow the increment on the unit x direction, that is delta x equal to 1, and the yk value you can compute yk plus 1 equal to yk plus m. This is the value, that is, we will follow the increment on the x direction, that is unit interval on the x direction we will follow, and yk we will compute based upon this equation. The next thing is that the second case from the assumption 1, that is, when the value of slope is greater than 1, strictly greater than 1. Remember that this thing is that this is strictly greater than 1. So in that case, when you are having the slope value, it is greater than 1, what we will do, we will follow the unit increment interval for the y direction, del y equal to 1, and the value of xk plus 1 we will compute it as xk plus 1 upon m. So 2 things should be clear. the position of the point, that is the starting point and the ending point. The second thing is that what is the value of m. If it is m is less than 1, we will follow this equation. If the value of m is greater than 1, we will follow this equation for computing the point. The second assumption, this is the assumption 2, that is we are having the second type of the case, that is when the line is processed from right to left. When we are having the starting point at the right hand side and the ending point on the left hand side, then in that case we are again having the two cases. The case 1, the value of m is less than equal to 1, then in this case the x value will be decremented. Look at this point, the x value will be decremented and the value of y will be calculated as yk minus m. And for the case 2, when the value of m is greater than 1, the value of del y will be del y equal to minus 1 and the value of x will be computed as xk minus 1 upon m. So you can say that in computer screen, the point is given, the starting point is given at this point, that is this is the starting point and maybe this is the end point. So when this is the case, that is when your case is given, that is the start point is given at the right hand side and the end point is given to the left hand side. So in this case we will follow these two cases, that is the case 1 and case 2. So in DDA algorithm or simple DDA, we are having 4 methods by which we can compute the point, or we can calculate the pixel value. The first method, the assumption 1, when the line is from left to right. Then we are having the case 1 and case 2, and the second assumption is that when the line is processed from left to right, right to left. So in this case we will follow these two methods. Most probably in the questions we are following the case 1 only or case 2 simply. We are not going to the case 3 and case 4. You can say that this is case 3 and this is case 4. So we are having 4 method in the DDA algorithm for calculating the pixel value. We can go for any one of them which is given to you. Based upon your requirement, we can interchange the values on the algorithm which is generated, the pseudo code of the algorithm. We can change the values depending upon that one.
This is the pseudocode given for the simple DDA algorithm. When we are having the case for left to right, that is the starting point is given to us at the left hand side and the end point is given to us to the right hand side. And the value of m or slope is less than equal to 1. This is the header file we need to include according to the device, and this is the round of the value. That is, when we are going to round up the value, it will be integer a plus 0.5. That is, we are going to use the integer values. This is the function for the DDA algorithm. That is, we are having the starting point as the input x1, y1 and x2, y2. You can say that here it is given xa, ya, xb, yb. You can use as per your abbreviation what is required by you. Now the function is started for the line DDA algorithm. It is saying that dx equal to xb minus xa or x2 minus x1. It is same thing. Dx is equal to delta x. Mathematically, we are using the delta x, but in practically or in the when we are writing the pseudocode, we are using dx. So this is xb minus xa or x2 minus x1, and dy is y2 minus y1, and the step and the number of iteration, the k, the index value we will use. The float value is x increment and y increment. The x is set to xa and y equal to set to ya. That is, the starting pixel or starting point is taken as x1, y1, and now the condition is started here if absolute value of dx. Remember that this is the absolute value of the dx. It is not the normal value. If it is negative value, we need to convert it to positive. That is the positive value we have to consider in any case. That is, dx is greater than dy. Then the step will become the absolute value of dx. Otherwise, or else the step will become absolute value of dy. If the value of dx is greater than dy, then we will consider the number of step dx, or you can say that which one is greater we will consider. In the case of dx and dy, the x increment, you can say that dx divided by the step. The y increment, the value of y increment is dy divided by the number of step. Now here we are going to set the first pixel at this place. Set pixel round x, round y. That is the first pixel we have setting at this place according to the algorithm. We will not follow our own algorithm because sometimes people are calculating based upon the mathematics directly they are writing. It is not correct. We need to follow the guidelines given by the algorithm because this is the simple DDA algorithm. So at this time, round x, round y, the value of x and y which we have taken at this place. So if it is, we need to round up the value. That is, if it is 0.5 or 0.7, some value is given, we need to round up the value based upon the algorithm. Now the iteration is started for the algorithm. This is the for loop. We are starting from the index value of 0, and the index value is going, iteration is going up to the strictly less than the step, and k plus plus. This is the simple for loop, and inside this one, the x equal to x plus x increment is given, and the value of y is given, y plus y increment. And after each increment, what we need to do, we need to set the pixel value, that is set pixel round x, round y. So this is the pixel value for the round x and round y, and this step will iterate up to the less than the step, that is the k, the value of k is strictly less than the step. So this is the DDA algorithm. We will solve the problem based upon this DDA algorithm. These two problems we are going to solve, and this is only for the first case. That is the case 1, when we are having the assumption the line will start from the left hand side and it will go to the right hand side. We will solve the for the second, third, and fourth cases also.
Now we will start from the problem number 1. What it is given to us, it is saying that rasterize the line with DDA algorithm, or you can say that simple DDA for the given start and end points for 0, 0 and 5, 5. That is, the start and end points are given to us as 0, 0 and 5, 5. So when you are going to start the problem for the DDA algorithm, what we need to do, you need to first check the slope, the value of the slope. M equal to, this is 0, 0 and 1, 5, 5. So this is x1, this is y1, this is x2, this is y2. So the value of m, or slope, will be 5 minus 0 divided by 5 minus 0, that is 1. That is y2 minus y1 divided by x2 minus x1. So the value of slope is m. So you can say that this is the case for the assumption 1, that is when your line is starting from left to right, because the value of starting point is 0, 0, so it is left hand side, and uh, the slope value is 1. So this is the case 1 for the assumption 1. That is when the slope value is less than or equal to 1. We will follow the first first case of the DDA algorithm, and the pseudo code what we have discussed, we will follow according to that. We will not do our own mathematical calculation. We will follow the guidelines which is given on the pseudo code, because sometimes people are solving the problem with the help of mathematical equations. It is not correct. We need to follow the strict guidelines which is given on the your pseudo codes, because that is the algorithm. Mathematically we can solve this problem, but exactly, because this is the algorithm for DDA, so we need to follow the algorithm of the DDA only. We will not follow our own method. So let us start for this one. X1, Y1 is given 0, 0, and X2, Y2 is given to us 5, 5. Next thing is that M we have calculated. So you can say that the case 1 we can apply the simple DDA algorithm. Now when we are starting, what will be the first step? First step is that we need to check the value of dx and dy. What is the value of dx or delta x? It is 5 minus 0, that is x2 minus x1, this is 5, and the value of dy is again 5 minus 0, so it is again 5, because both values are same. If you will see from the algorithm which is given to us, the pseudocode is given to us, it is saying that if dx is greater than dy, we need to follow the first case, otherwise we need to follow the second case. But here the cases are same. So number of step, how you can decide the number of step? You can follow any step, because it is 5, 5. So we will follow the step number 5. That is, we will get step 5. The value of step will be 5 here. So what about the next thing we need to calculate? The next thing we need to calculate is the value of x increment and y increment. So x increment, how we can calculate the x increment? It is dx divided by step. X increment dx divided by step. So the value of dx is actually 5 and the step is 5. So x increment, value of x increment will be 1. And the value of y increment, it is also dy divided by number of step. It is 5 upon 5. So this is 1. Now what we need to do, because according to the pseudocode we need to calculate the first step, that is what is the first pixel of the screen, that is we need to set the pixel. If you will see from the algorithm, what is the first pixel value? The first pixel value, it is saying that it is x equal to 0 and y equal to 0. The same first step we will get from here. The starting point, you can say that, because the round off value, it is 0 0, so there is no need for the round off. It is 0 is 0 and y for the 0 is 0. No need to round off. So let us start the algorithm from the step. How many things we need to calculate? First thing is that the k, number of step. Second thing is the pixel, the calculated pixel, and the third thing is the value of x comma y. This is the calculation we need to calculate based upon the pixel value, based upon the x and y. The starting point or starting pixel is 0 0 according to the algorithm. This is inside the for loop. If you will start from the for loop, the number of step is 5. So loop will start from 0 and it will go up to the 4, because this is 0, 1, 2, 3 and 4. The maximum time this loop will iterate up to 4, because the value of step, the value of k is strictly less than the number of step. So it will start from 0 and it will go up to the 4, because the value is here, we have calculated 5, so it will go up to 4. Now the first pixel we have calculated 0 comma 0, so we will start from 0 comma 0. X and y, the first pixel of calculated is 0 comma 0. The next thing is that the value of x and y, how we will calculate the value of x and y? We will follow the formula x equal to x plus x increment and y equal to y plus y increment. This is the formula which is given in the pseudocode inside the for loop, if you will see. So the value of x we can calculate, x is 0, the starting point is 0, so we will take it as 0. The next thing is x increment, so plus, what is the value of x increment? X increment we have calculated here, it is 1 at this time, so add the value 1. Same thing for the y, it is y plus y increment, the starting point is 0, so it is 0 plus 1, because the y increment is also 1, so it is again 1. What is the next step inside the for loop? If you will see from the algorithm or in the pseudocode, you will see that we need to set the pixel, because here the value of x and y is 1 1, so no need to set a round of the value. So the pixel value you will come from here 1 comma 1. This is the simplest DDA problem, so you will not get some complexities. In the later question, you will get some complexities. That is when we are going to round up the value. Here we will get directly the value. So first thing is that we have to calculate the first pixel. Next we need to calculate these two values, x and y value, and based upon these value we need to round up the value, that is 1 comma 1 for this time. The same thing next time we need to again iterate. Now at this time we will not consider this pixel for the calculation purpose. We will calculate the value of x and y from this place only. So the x is 1 and y is 1 at this time. In the present situation, in the second iteration of the loop, the value of x is 1 and y is 1. So again, for the second iteration, x equal to the value of current x, the previous x is actually 1 and the x increment is already 1, so 1 plus 1, and the value of y is again the same thing, it is 1 and this is again 1, so it is 1 plus 1. So you can say that we can set the pixel value, it is 2 comma 2 at the step number 2 or iteration number 2. Same thing, we need to iterate it again and again. This is quite simple, you need to understand. We have to start from dx and dy. First we need to calculate the value of m. Next we need to calculate the value of step. What is the value of step? Based upon the dx and dy value, which is greater, we will consider that value. Dx is actually mod dx, because we will not consider the negative value, we will consider the positive value. Step equal to 5, x increment, y increment, and we need to set the first pixel value, that is x equal to 0, y equal to 0, because our starting point is this one. So based upon the first pixel, we will start our iteration. So y equal to 1 plus 1, the same thing we need to do again, x equal to 2 plus 1 and y equal to again 2 plus 1. So you can set the pixel value 3 comma 3. This is the second iteration. Next, for the third iteration, this is x equal to 3 plus 1 and y equal to 3 plus 1. So you will get x equal to 4 comma 4. In the next iteration or in the next step, this is again 4 plus 1 and y equal to 4 plus 1. This is 5 comma 5. And when you will see, this is the last step, when the value of k will become 5, we need to get out from the for loop, and this is the last step. And if you will see, this is the last pixel, or you can say that the end point of the algorithm. That is, we started from 0 0 and we reach up to the 5 comma 5, that is the end point of the algorithm or end point of the line. So you will get this value. So our pixel will be these are the list of our pixel, that is the first pixel, the second pixel, which is calculated from the iteration. This we have calculated before the for loop. If you will see from the algorithm or pseudocode, this pixel we have calculated at before starting the for loop. So this pixel we have set the first pixel. This is the second pixel inside the iteration 1 comma 1, 2 comma 2, 3 comma 3, 4 comma 4, and 5 comma 5. We reach to the end point of the algorithm, or we reach to the end point of the line. So this is all about the first question. We will start for the second problem. Now this is the second problem. In this question, it is given rasterize the line with DDA algorithm for the given start and end point 0 comma 0 and 8 comma 4. This is also the case assumption 1, that is the starting point is at the left hand side. We can identify the this point is starting from the left hand side or right hand side by directly watching the values of x. That is, the first value is 0 and this value is 8. So this is greater than this one. This value is less than this value is less than this one. So you can say that the starting point is at the left hand side of the algorithm. Remember that in DDA algorithm we cannot interchange these values. We have to stick on the things, that is, if it is given at the starting point, so we will start 0 0 as the starting point. We cannot start from this point or this point. Okay, so what is given to us, we will start as it is. We cannot change the we cannot interchange the values. So it is given to us 0 comma 0 and 8 comma 4, or you can say that again same thing is given to us, that is x1 comma y1, and this is x2 comma y2. That is, this is the starting point and this is the end point, and easily you can identify this is the case for the left to right scanning. And first we need to calculate the value of m. This is y2 minus y1, this is 4 minus 0, and this is x2 minus x1, this is 8 minus 0. So you can say that the value of m is actually 0.5. It is the case for the less than equal to 1. This is the case for the when the m is less than equal to 1. So we will follow the first case for the simple DDA algorithm. So let us start for the step 1. What we need to do? We need to calculate the value of dx. The value of dx you can calculate from here. It is 4 minus 0. This is 4. Sorry, this is 8 minus 0. This is 8 minus 0 equal to 8, and the value of dy is 4 minus 0 equal to 4. So because dx is greater than dy, the mod of dx is greater than dy. So number of step you can calculate as per the algorithm. It is 8. That is, this algorithm will iterate, the for loop will iterate up to 8 points. That is, from 0 to 7 it will iterate. So the number of step is actually 8. The next thing is that we need to calculate the value of x increment and y increment according to the algorithm. So we need to calculate the value of x increment. This is dx upon step. So dx, the value of dx is 8 and the number of step is 8. So x increment is 1. The next thing is that about the y increment. This is 4 upon 8. So the value of y increment is 0.5. The next thing is that what we need to calculate, the starting point or starting pixel. The starting point is given to us x equal to xa or x equal to x1, it is 0, and y equal to ya or y1, it is given to us 0. So x and y, the starting pixel will be 0 and 0 according to the algorithm. We are following the guidelines of the algorithm. The next thing is that after setting this one, because there is no need for the round of the values, so we will get the 0, 0. Now let us start the for loop or start rasterizing the pixel for this line segment with DDA algorithm. So what we will do, the first step is the value of k, that is the number of step. The next is pixel, which we need to calculate, and the next thing is the value of x and y, which is used for the calculation purpose. The first point is 0, 0. So the first pixel given to us is 0, 0, which we have already calculated or we have already set. The k will start from 0 and it will reach up to the 7, because the value of k according to the algorithm, it is saying that it is strictly less than the number of steps. So it will start from 0 and it will reach up to the 7. It will not go beyond the 7. So we will start from 0, and the pixel value we need to calculate according to the algorithm, that is x equal to x plus x increment and y equal to y plus y increment. This is the formula which is given in the pseudocode. You can watch from the pseudocode. Now what is given to us, x equal to, this is 0, or the starting point x1, it is 0, plus x increment is given here 1. So it is 0 plus 1. The next thing is that y equal to 0. The starting point of y is 0. But what about the y increment? This is given to us 0.5. So it will be 0 plus 0.5. Now what we need to do? According to the algorithm, we need to set pixel. That is, we need to round off the values of x and y. So after rounding off the value of x and y, x is 1 and the value of y is 0.5 plus 0.5. So it will become 1, 1. This is the first pixel. we have calculated. In the next step, that is when for the second iteration for the for loop equal to 1. Now again start x equal to, this is 1, we have calculated. We will not calculate the value of x and y from this one because this is the pixel value. We have already rounded off this value. We will calculate the value of x based upon this one. That is from this point we need to calculate. The value of x and y will come from here. It will not come from at this place. Okay. So x equal to 1 plus the x increment is 1. So it is 1. The next thing is about the y. The value of y is 0.5 at this time. So 0.5 plus 0.5 because y increment is 0.5. So it will become 0.5 plus 0.5. So for the first step, the value you can say that the pixel value will be 2, 1. Here no need for the round of the value because the value of x and y, it is already 2 and 1, that is the integer values. So you will get 2, 1 at this place. For the next step, for the step number 2, same thing we need to do. X equal to 2 plus 1 and y equal to, this is 1. At this time, this is y equal to 0.5 plus 0.5, it is 1 plus 0.5. So the value of x is pixel 3 because there is no need to round off the x value, but we need to round off the value of y. It is 1 plus 0.5, and based upon the pseudocode, we need to add 0.5, that is we need to round off the value, so it will become 2. That is 1.5 plus 0.5, it will become 2. So the pixel value will be 3, 2. For the step number 3, the same thing we need to do, iterate again x equal to 3 plus 1. Remember that the value of x and y we will need to calculate from this place. We will not use these values for the calculation purpose because this is the pixel value. We have already rounded off the value. So y equal to 1.5 plus 0.5. So the pixel value for the third iteration will be 4, 2. For step number 4, same thing. If you have calculated 1, you can iterate the step again and again until we need to reach the step number 7. X equal to 4 plus 1, y equal to 2 plus 0.5. So it will become 5, 3. For step number 5, this is same thing, x equal to 5 plus 1 and y equal to 2.5 plus 0.5. So this will be 6, 3. At step number 6, x equal to 6 plus 1 and y equal to 3 plus 0.5. So x will be 7 and y equal to 4. At step number 7, x equal to 7 plus 1 and y equal to 3.5 plus 0.5. So the value of x pixel is 8 and y pixel is 4. So at step number 7, because this is k is less than, is strictly less than, this is not less than equal to, this is strictly less than to the step. So we need to stop the for loop and the algorithm will stop at this place. That is, we got our all the points, that is starting and end points at this place. This is the starting point for the algorithm, that is the first pixel of the algorithm, and this is the last pixel of the algorithm, which is nothing but our end point of the algorithm. So we have calculated all the pixels, but remember that when you are calculating the value of x and y, we need to follow the starting point and end points. We will not use these values. Remember this thing always. We will not use these values. We will use the values of x and y from this place only for the iteration purpose. This is the rounded off value, which is based upon the algorithm. So this is all about this problem. That is simple DDA for the assumption 1. That is when our scanning is from left to right. That is when we are having the scanning from left to right and the value of m is less than equal to 1. This is the first case of the algorithm. Based upon this one, you can calculate the value for the case 2, case 3 and case 4. That is when we are starting our algorithm from right hand side to the left hand side. That is the further assumption 2, that is right hand side and left hand side. Suppose that if you want to interchange the point 8, 4, the starting point and the ending point is 0, 0. So you cannot interchange the values, you cannot interchange the points. If you want to start this thing, we have to start from this point only, and we need to follow the cases based upon that one. We will discuss them later in the next section about that cases, that is how to calculate the values when we are having a situation about this thing.